Hello class, this is going to be a short lab help session with this lab, which is Subsidence lab from chapter 8, I believe. Okay, so this is a fairly straightforward lab, so it won't be of a whole lot of help, meaning much of it is pretty intuitive. The only thing I'm going to do is pinpoint things on the images and the tables that you should be looking at when the questions are asked mostly. It's not very mathy either, so that shouldn't be much of a problem. Okay, so I'm going to skip through this whole introduction and part 1 description. You should definitely read it. That's how you're going to be able to answer the first few questions within here. So the first question asks, the sediments in major areas of subsidence consists of interbedded clay, silt, and sand and gravel. Which of the following characteristics apply to clay silt? So here you're going to choose many of these characteristics, so it can be 1, it can be 2, it can be 3, 4, 5, 6, 7, or 8 even, if you think that those characteristics apply. Same thing for the second question, is the same options, however in this case you will not be talking about the clay silt, but the sand and gravel. So if you have read through this whole part, a hint is that clay, silt, and sand and gravel behave very differently, so most likely the characteristics that you choose for question 1 won't be the same ones that you choose for question 2. They will rather be the opposite ones, okay? Alright, so for question 3, subsidence induced by groundwater withdrawal generally occurs in areas characterized by confined aquifer systems. What is a confined aquifer? So that you can either find in the beginning of the lab, or you can also find it from lecture or your book. Confining beds, number 4. Confining beds consisting of clays and silts, respond differently than sand and gravel. They may contain a great deal of water, which means that they have a high porosity, but it is not readily transmitted. Such rocks have low, so the fact that even though they have high porosity, that water that is contained within is not easily transferred from pore to pore, from space to space, means that there is a low something that is restricting the water from flowing, okay? So that's a big hint. Again, I believe that the beginning of this section, this part, will help you with that, as well as lecture or the book. Okay, part 2, subsidence in the Santa Clara Valley in California. So in here, this is where I'm going to point out the different figures that you're going to use from the attached PDF document also on Blackboard. So that document should look something like this. This is going to be the first figure within there. And you have, I think, 8 different figures / tables to look at. So that's on Blackboard. If you can't access it for some reason, let me know and I'm happy to give it to you. Otherwise, you won't be able to complete this lab. Okay, so I'll skip through this until we get to different areas. Okay, so below a depth of 200 feet, the groundwater is confined by layers of clay except near the margins. So it says to refer to figure 1. So let me point that out for you. So this is figure 1, the first one that's on that document. And here there are pinpointed within the figure, like a cartoon of how that valley looks, the Santa Clara Valley. So here, this darker brown areas are the clay layers. And as you see, those clay layers lie mostly in the middle of the valley, not towards the sides of the valley. Okay? Oh, sorry. Excellent. So let's go down here. Most of the wells tapping the artesian system range from 500 to 1,000 feet in depth, although a few reach 1,200 feet. Well yields in the valley range from 500 to 2,500 gallons per minute. So refer to figures 2 and 3, which show land subsidence for 2 different periods to answer the following questions. So I'll refer to these figures as we go through the questions. Okay, according to figure 2, what locations showed maximum subsidence in the Santa Clara Valley between 1934 and 1960? So if you go back to the document, figure 2 is this one, and it's not as easy to see. As you can tell, it's pretty old. But below, in the bottom of the figure, let me see if I can expand this view for you. Here in the bottom of the figure, you see that the years that they're accounting for in the subsidence is from 1934 to 1960, which is what the question is asking you. Okay, those years, that range of time is where the question is asking you. Okay, so what you're seeing in the map itself, in the image, is a set of, obviously, the map of the areas. Here you have the Santa Cruz Mountains, you have the Diablo Range, you have the San Francisco Bay, and you have the Santa Clara Valley right here. So if you think about a cross-sectional line, a line taken here through this valley, that would be pretty representative of how this diagram right here kind of looked, right? Excellent. And so all of the lines that you're seeing that are between the valley, like inside of the valley, that are not crossing one another, but are kind of concentric, meaning they're making sort of circle-like shapes or oval-like shapes, those are contour lines of subsidence. So, for example, some of them are dashed, meaning that they're not necessarily sure that they happened there. They could have been a little bit off, but you see some numbers attached to them. So over here you see one that is dashed and it says 0.5. Then below that, or to the west of that, there's one that says 1. Then to the west of that, there's one that says 2, and that one is definitely kind of wrapping around, or easier to follow the wrapping around of it. And there's one below that that says 3. Same thing, if you wanted to, you could probably track them down, right? Then there's one that says 4, and then you see 2 smaller ones that say 5, one down here and one up here. Okay, so hopefully you see that. And there are a few towns for you to refer to in terms of answering the questions. So you have Alviso right here, you have Agnew. Well, I'm not really sure how you say it in English, but that's how you would say it in French. There's San Jose there, Santa Clara there, Campbell there, Mountain View, Palo Alto, Redwood City, Menlo Park, so on and so forth. So when you are answering the questions, make sure that you use the reference locations as, I guess, as a reference. So for example, in the first question, or the fifth question, sorry, where they asked you, according to figure 2, what location showed maximum subsidence in the Santa Clara Valley, you would say, okay, so if my subsidence is 0.5 right here, 1, 2, 3, 4, and then 5, which is the highest number that I see in these locations, then you would say, you know, the maximum subsidence appears to be between Mountain View and Alviso, as well as near San Jose, like a little bit east of San Jose, or something along those lines. Okay, so that would be the way that you answer the questions. And again, that's how they're going to be placed on Blackboard as a quiz. Okay, all right, so let's go down the question. So what was the total subsidence from 1934 to 1960 in these areas of maximum subsidence? So based on those contour lines, again, you can tell me what was the maximum subsidence. All of these are measured in feet, just so you know. Okay, so what was the average annual rate of subsidence in these areas of maximum subsidence from 1934 to 1960? So the way you do average annual rate of subsidence is you take the subsidence that happened between all of those years, which you found from the contours, right, wherever you found the greatest contours, and you say, okay, if I had, let's say, 100 feet of subsidence over however many years there are here, then that's your annual rate of subsidence. Okay, so that's how you're going to answer question 7. All right, what geologic material is largely responsible for the subsidence? You're going to be able to answer that question based on the reading that you did before in the area above. So I'll let you go through that. All right, would subsidence be more noticeable at Alviso, which is on the bay, or at Mountain View? So for example, if we go back to the map, you see Alviso is right here, so it is touching the bay, and then Mountain View is here, closer to the mountains. Both of those locations see similar amount of subsidence, so you see this 4-foot contour line of subsidence pretty much touching both of those locations. However, one of them is near the mountains and one of them is at the bay. So which of those two locations would basically have a more noticeable subsidence check and then think about where they are located and how you could tell the effects of that subsidence more so. Alright, and then would you expect any subsidence in the areas marked with diagonal lines? So those areas that they're referring to is this whole surrounding area, right? Pretty much where the Diablo Range is here, south of the valley, and then towards the Santa Cruz Mountains. So I'll let you think about that, and also based on this figure right here, you should be able to answer that, I believe. So again, this image right here is basically a line where you cut through the earth as though you had cut through the earth here, okay? So I'll let you think about what type of rock you have in these locations. You can also see that from the legend, the explanation here. So that will help you answer that question. Okay. So figure 3 now shows the total subsidence for the central part of the valley between 1934 and 1967. So here, let's look at the image. So here they give you the whole subsidence rate, or the subsidence itself, in that area for the whole 33 years. And so now they're asking you, what was the annual rate of subsidence for the area around the highway junction, which is Bayshore Highway and number 9. This is north of Sunnyvale and east of Mountain View. So if we go to that location, so we have Mountain View right here, and we have Sunnyvale right here, and we have the Bayshore Highway number 9 right here. So it's hard to see, that's why I'm pointing them out in the video. So they're referring to this area right here. So you can answer that question. And then remember that here they're asking you for the annual rate of subsidence. So you need to take into account the years in between and then the amount of subsidence that there was between those years to answer the annual rate of subsidence. Alright, so where had the maximum subsidence occurred in 1967? So you take the map and you see what the greatest contour number is, and then you find a location that is nearby that number, and basically you say is it's northwest, east, south of whatever place you find. Excellent. Alright, so what was the increase rate in subsidence between 1960 and 1967 on the Bayshore Highway south of Anu? Alright, so if we go to that map again, let's see. So Anu is right here, right? And just a little south of it, this is the contour that we should be looking at. So what you have to do is you have to look at both figure 2 and figure 3. So when you look at figure 2, find Anu, and this is where that location was. So it's somewhere between 4 and 5. In figure 3, that location's at 8. So you subtract 4 to 5 minus, or sorry, you subtract 4 to 5 from 8, and that's the amount of subsidence between 1960 and 1967, and then you take into account the number of years that are between those two dates, and you have your rate of subsidence. Okay. So this next part deals with mostly figure 6. Figures 4 and 5 are just for you to look at the different effects that the subsidence had. So this is figure 4, looking at the well screen and how it was damaged. And then this is figure 5 at the yacht club in, I think it's Alviso. Yep, Alviso. So you see some of the effects that happened from the subsidence. Alright, and this is figure 6, which deals with what you need to answer on the following questions. So, the fluctuations in water level in an 840-foot deep well in San Jose are shown in the hydrograph in figure 6. So those are the image I just showed you. This record shows the changes between 1915 and 1967. So first question for that figure. What was the water level in the well in 1915? So if you look at this graph, you have dates on the x-axis down here, and you have water level on the y-axis and subsidence in the y-axis as well, but on the opposite side. So basically these are sort of related, right? The water level gets lower and the subsidence of the soil also gets lower as the date continues to go on forward.